here we go. It gives us two formulas. This converts Fahrenheit, or I'm sorry, this converts Celsius to Fahrenheit, and this converts Kelvin to Celsius. And so we need to write something that converts Kelvin into Fahrenheit. And so they tell us that f of x is going to be the thing for Fahrenheit. Then they tell us that g of x is the expression that does the conversion in Kelvin, right? And so I probably should highlight that x then would represent temperature in Kelvin. And I want to draw a quick diagram before we dive into the math. Here's what this is what is really going on, okay? And then I'll talk about this notation, and then we'll go from there. I'm going to have a function. Oops, wrong one. I'm going to have a function, right? And that function is going to have an input and an output. Whoops. That last one got a little crooked there. And so, essentially, this is f. Okay? And what does f do? Well, it takes a temperature that's in Celsius and spits it out to Kelvin. Does that make sense? But what we really want, wrong one. I'm going to have to move some things here. Oh wait, I gotta correct something. I'm sorry, I wrote some things wrong. It doesn't want Kelvin. What it's going to do is it's going to take Celsius and convert it to Fahrenheit. And we'll use the capital letter F. All right. But we're starting in Kelvin because X represents Kelvin. So then I've got another function and we'll call this function g that actually takes Kelvin and converts it to Celsius. So I plug in a value for K, and so we call this one g of x because we're letting x equal Kelvin. And then it spits out a y value, or an output. We'll just call it an output. So this is the output here. That's in Celsius. But then it's the input for f? Well, the input is x as well. So this is an output for g, but it's also an input for f. So it's still an x value, right? Because this is x. Technically, it's g of x, if we want to think of it that way. So this x value is actually g evaluated at x. Well, let me change the right color. So my input is the output of g of x, okay? And then finally, I'm going to have the output. Whoops, wrong color again. Dang it. Which is lowercase f of x. So now, in order to do that, really what I could do is I could take this g of x and input it into f of x. That's what this is. Down here below, they're saying write an expression where you have f. Now, normally we would say f of x, but what are we going to plug in for f of x? The value of g of x, right? So I'm going to say g of x. Now, this is really confusing to do sometimes because you have to keep track of stuff. If you have two colored pens, I recommend you use the two colored pens. It really helps keep track of stuff. So what I need to do first and foremost is I'm going to write f of x, but wherever there's an x, instead of putting an x, I'm going to put g of x. So I'm going to say 9 over 5, and then I'm going to plug something in here for x, right? I'm just copying this, plus 32. Okay? Does that make sense? And then I'm going to write in g of x. So then, what's g of x? So on my next line, when I say f of g of x, I'm going to write 9/5 times what is g of x? X minus 273. Now, this is very reminiscent of solving systems. Remember when you do systems of equations by substitution, where you substitute one into the other one? This is very similar to that. I think the part that's hard about this is you're plugging in an x into an x. I have found through the years that when you write all these steps out, in other words, when you write it with the g of x in there, and then take a second step, and you could even write it like this. This actually is how I usually do it. I plug it in here. So I would say something like f of, and then I would actually plug it in right here. I would say x minus 273. Now, the hard part about this is you got to do a little bit of algebra. So my f of g of x I got to push this 9/5 through, which is not fun. So I'm going to say 9/5 x, but that's okay. We have these fancy calculators. Now, it would take me a little bit of work to do this 9/5 times 277 type situation. But on my fancy calculator, I can just, if you guys hit math and you go to number, oh, on your old calculators, it might not have it. So we'll just pretend it's an old calculator. So just say 9 divided by 5, and then multiply that by, was it negative 273? Yeah, negative 273. So we're going to say negative 273. Now it's going to give you a decimal, right? Now, does anybody in here remember how we convert a decimal to a fraction? You could leave it as a decimal if you had to, but if you hit the math button, see this first option, it takes whatever your answer was and converts it to a fraction. So we'll see if it works. Yep. Whoa, let's just leave it as a decimal. Okay, I'm okay with leaving it as a decimal. So that became minus 491.4. 491.4, but then we have to add 32 to it. So if I go back to my calculator, remember I can copy and paste my answer by just highlighting it and then hit enter and then add 32 to it, and I get minus 459.4. So on my very next line, I'm going to say f of g of x equals 9/5 x minus 459. Oops. Minus 459.4. And that's it. Okay. Any questions? So I'll leave that up for a second so you guys can finish copying it.